Here we have product rule again, so let's do it. So first, secant of x squared times the derivative of 4 to the stuff, 4 to the stuff, ln of 4, 3x squared, plus, and I'll carry along this 4 to the x cubed, derivative of secant is secant tangent, carry the angle along, and then multiply by the derivative of the angle, which is 2x. 2x. Okay, let's finish this one here. Okay, pi squared is not a function. It's just a number. So to take the derivative, I'm going to carry the pi squared along, take the derivative of the secant, which is secant tangent, leaving room to carry the angle along, and then now take the derivative of 2 to the x, which is 2 to the x ln of 2. Okay, so let's go to this next one here. So the derivative of 3 to the stuff is 3 to the stuff times ln of 3. Now to take the derivative of cosecant, it's negative cosecant cotangent. I carry the pi x along. I'm having pen issues here. So pi x, and then at the very end, I multiply by the derivative of pi x, which is pi. Now we're going to move into some applications. So when the particle is at rest is the same thing as saying when the velocity is 0. And if I have the position, you know that the velocity is a derivative. So the derivative of e to the stuff will be e to the stuff times the derivative of stuff, which is 3t squared minus 2t. Setting this equal to 0. Come on, pen. Doing it again. Equal to 0. So now you know this never equals 0, right? E to anything never equals 0. So I only have this. So be careful. I'm going to start writing it up here. 3t squared minus 2t equals 0. Do not divide through by 0 because you lose an answer. So if I factor out a t, I get 3t minus 2 equals 0. That gives me t equals 0 and t equals 2/3. So there are 2 times that the velocity is 0. Let's go and do this one. So this one here, I'm going to take the derivative to find the equation of the tangent line because that's how I find the slope, and I've got the x equal 1 for the point. So let's go take the derivative. So I get a 1/2, carry the inside along, x cubed plus x squared plus 7, and then times the derivative of the inside, which would be 3x squared plus 2x. I'm going to take the time to rewrite this, and I'm going to use a lot of space here. I'm going to take that negative root and put it in the denominator. It's so much easier to see what numbers are happening when you've got negative exponents if you write them in the denominator. So now let's plug in x equal 1. So y prime of 1, putting in 1, I get 1/2, and down here I get 1 plus 7, and on the numerator here I get 3 plus 2. So this gives me 5 over, and then I know that in here I get a root 9, which is a 3 times a 2, that gives me 6. So that's our slope of our tangent line. I have the x equal 1. To find the y value, I put it into this function. So let me erase here so I can make some room. So I plug that x equal 1 into the function to find the y value. So f of 1 gives me 1 plus 7. Oh, I get the same thing, the root 9, so that's 3. So the point is 1, 3. The slope is 5 over 6. So again, you put together the equation of the tangent line, which we've done lots of times, x minus 1. And there we go. Let's do another here. So find the angles theta where the tangent line is horizontal. So you know that means where the derivative is equal to 0. So that's going to happen a lot. So let's take the derivative. So y prime will give us a negative sign, carry along the angle, times the derivative of the angle. and I'm going to set that equal to 0. So you can see I can divide both sides by -4, right? So I end up just getting sine of 4 theta is 0. So thinking on your unit circle, it's going to be 0 or pi, that the angle, that the sine of the angle will be 0. So I can say that this 4 theta is equal to k pi. So the answer will be k pi over 4. Let me stop here.